So today we get a hard problem: maximum profit from trading stocks with discounts. That always smells of GP every single time, but this has funny constraints. So let's see. Number of employees, they have an ID. One based integer, present and future. So present is the current price at which, okay, hierarchy is a graph, budget total finds available. There, if an employee's direct boss purchases their own stock, then the employee can buy their stock at half the original price, return the maximum profit without exceeding the budget. That's interesting. So what are the prices? Budget is 160. Oh, okay. So let's think about this. A lot to unpack here. So they all buy today and then they sell tomorrow. So this is what you can gain. Okay, so I'm immediately thinking of, brute force would be just, let's say I'm here and then what I have an option. Well, I buy or I don't buy. If I don't buy, then I just get the answer for here. And if I buy, then I get if I buy, then I tell this guy that I bought so he can buy it at a discount if he wants to. That's it. And we just do it smartly. Okay, that's brute force. Now how to optimize that? Well, we wanna, since the budget and the number of vertices is small, what we can do is maximum gain we can get by using whatever part of the budget. So we got N, we got present, we got future, we got hierarchy. So let's make a graph, I guess. Vector int gn gh0 h1 Fair enough, so we got a graph. Let's do B because I don't want to type budget every time. And now, well, what we need some dynamic programming on vertices and budgets. So dpij is profit over vertices and over the budget. Max profit should be -1 so that we cannot even get that amount, and then, or does it have to be, let's make it 0 and auto function void, and we take, I'm not sure what, let's keep it this way, capture everything so that it's not slow. That's our inline DFS, and then we run DFS. Could probably include some more here. vector, I think this means that, well, we don't know, our parent is that, and so we keep the parent, we keep if we bought from the parent, we didn't, and then our budget left is B, or budget used, sorry, so what we use. Do I need it? We'll see afterwards. So and the return value also return 0 for now. So when we are in a DFS, if there are no kids, then it doesn't matter. So what we need to do is where we are, our parent, and if he bought, and so if GV size is 1, meaning we only have our parent, then what we want to do, well, we want to buy, let's say we buy at DP well, if there is 1, so we should say that by using budget so profit in vertex V by using budget, so this is that depends if the parent bought something. Do we don't care because we are trying all solutions, I think, maybe, I'm not sure. So profit of maybe I don't even, I need the parent for DFS. So profit of, so int cost 1 will be future V, and it's gonna work, fair enough. So future V minus a present V, and then cost 2 is gonna be future V minus present V divided by 2, and now profit C1, so meaning we, well, if we, no, if we didn't buy, or that means our parent didn't buy, let's say we didn't buy, yeah, that's gonna be tough modeling this. Maybe I should start from backtracking. I think I'm on the right path, but I will just need to crystallize the idea more. Let's just start with this DP and try to make it work, and if it doesn't, then maybe we'll find out something. So profit of, now what was the cost? That's profit 1, profit 1, profit 2, and int cost 1 is present V, and present V2, fair enough. And so with C1, and we don't know if the parent bought it, so we pretended if our parent bought it, right? So now if our parent didn't buy it, then the profit is equal to P1 profit V, and if our parent did buy it, then our profit is the other profit, and we return, of course. Now so what we do, well, we run it first for the children. If U is not parent, VFS UV, and after we compute the answers for children, I need to somehow calculate them together. So for each child, so let's say I don't buy here. Let's say we don't buy. Okay. So let's say I don't buy. Then I'm interested in values that my boss did not buy, so which are 0 values in there. So this is just for calculating. Now we need to go through, so we need to compute these values for this vertex. Now that we have computed those values, then the answer should be in DP 01 0 0 because his parent did not buy. Okay, and now that we got with this cost, so we want to start from int current budget is equal to cost 1, and the cost 1 means that our parent did not buy, and we go up to budget. So this needs to be budget plus 1, so this means how much we used up, and CB plus plus. So this should be minus 1, I think. And then what we want to do, well, we want to get the sum of children over, so 4 in the U in GB. If U doesn't equal parent, then what we want to do, well, we want to produce some, so int current profit is 0, or current profit is profit 1. That means that we bought this, oh, I forgot about the option of not buying. So profit 0, profit V 0 1, so if our boss didn't buy, this is the cost. If our boss did buy, this is the profit, and these are the costs respectively. But we could also not buy. So our profit, if we don't buy and our boss doesn't buy, is the same as if we don't buy and our boss buys, which is 0. Shit. Fuck. I almost puked because my gas from stomach pushed out the stomach acid to my mouth, whatever. Okay, so we are pretending that we buy, and then once we bought, no. So, okay, we bought. Does it matter? Because we bought, so we are only interested in child. So current profit plus equals DPU at CB minus C1. So and DPU CB minus C1, 1 doesn't equal minus 1, then DPU this, and after we got the current profit, we had our profit of P1 there, so I mean, none of our children could still buy, so I mean, not buying is always an option, I guess, so maybe I can set it all here. So what do we do? Well, we bought here, but our boss didn't buy. So DP CB is equal to, no, DP vertex CB and our boss didn't buy is equal to current profit, maybe, I'm not sure. And then we do the same thing for current budget is C2, current budget, current budget, current profit, profit 2, we go over the because this is absolutely the same, whatever. DPU is not P, and DPU of CB minus C2, our boss did not buy, doesn't equal minus 1, then CB plus equals DPU current budget minus cost 2 of our boss buying, and then DPV CB our boss wait a minute, our boss buying is equal to current profit, and finally we go over the case where we didn't buy anything. Current budget is 0, current budget is it's 3 loops, so it's kind of bad, but current profit is 0. If u don't equal p and dpu cb, our boss did not buy. dpv max dp vcb1. Okay, and then what we want to do is dpv cb. Now what? Our boss dpv cb1 is current profit, and then we want to return int max for int current budget max dp 0 current budget 0. I forgot. Oh my days, everyone wants something. Okay. So DP. Oh my days. Let's call it DP. I don't want to write profit at every position there. I try to call it smarter, but in the end I just use DP. Where does this even die? Oh my god, bro. What? Hierarchy? What's a hierarchy? You, what the hell? So n is 2 and hierarchy says 1. What the hell? Why I get an overflow on this line out of all lines? Because minus has to be in front. Whatever. Okay, so okay. Well, you get 3 from this and 2 from this, so let's go for so if we do not buy anything, then no matter what our boss did, we get nothing, which should not be true. Why for this vertex it's all -1s? 0 and -1, so we never even and gb 0 is equal to parent. So let's say that with budget 1, if he didn't buy, we are cooked. But if he did buy, blah 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 blah. If he did buy, then we are fine. And with budget 2, we can buy for 1. With budget 3, I mean, technically cannot buy anything, but it does make sense to fill this option because it would get used and it would not be optimal. So optimal would be to use this. So no matter what our boss does, if we don't buy anything, we are easy, we are chilling. So this is filled correctly. Now with no budget, well, we get nothing. So wait, yeah, with no budget on our sub 3, with budget 1 on our sub 3, well, this is not a good price, 6, but if we get a budget of 1 and we buy this, that's very free. Okay, now if we have a budget of whatever, that is weird, bro. So if we have a budget of 2, we should be able to buy the whole thing, because say our parent did not buy, so so we start from, we need budget 3 for this, and so let's say our parent bought, so we can get a profit of 4, and we also bought, so okay, so if we have a budget of 2 and we buy this thing for 1, this absolutely doesn't work, so this does if our parent didn't buy. So this goes over. The current profit is profit 1, which should be 3, and it's 11:30, bro. I'm not gonna bake anything at all today. That's bad, bro. Whatever. So we go, so let's say our current budget is 2, and we buy something for 1, so we are left with 1 money, and our parent bot, so that's exactly what we should get over. So if v is 0 and u is 1 and cb is 2, then solve dpu cb minus c1, solve c1 cb minus c1 1. See what this outputs. So you can get 2. So if this is the case, then what's gonna be the profit, man? If VU off, if V0 and current budget 2. We are at 31 minutes. I can get that. So profit is 5. So and where is the 5, dude? Where is the 5? So DP vertex sort DP V this current budget. I mean, it should not be set yet, so I don't understand. So it was -1 before, and then it's 5. Where is it 5, dude? Can you please tell me where is it 5? What the freak, man? What the freak? Oh my god. I don't know. DPV CB 0 1. No way it passes all the tests. Let's delete the prints. Time complexity is not great, but constraints are pretty lenient, so let's see if we can do this. Immediately overflow. Holy shit. If C1 is less than budget, if C2 less than budget, let's try use test case. Boom. Okay, 790 tests. Output is that sucks. So I mean, it goes to both children, so budget is 28. If I buy here, I can buy everything. So I buy here for 6 8. Profit's gonna be 42 plus 44 plus and B2 is over 0 and I'm actually outputting a less. That's not good. If I reduce this to like 12, no, 11, then profit here is 6, and then I get a 44 and 46. So let's see. So if we don't buy anything, it's 0, and then we budget 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can buy this for 6. With budget 2, we can buy this for 46. And then with budget so the parent did not buy, so we are in this case. It's current budget minus so I have 4 budget left. Yeah, that's not good. I did not get far because my algorithm doesn't work. Because, I don't know, there's 6 hints. That is crazy. I mean, that's a good problem. Where can I like it? You cannot like problems anymore? Or am I just blind? Oh, here. That's tough because what I'm saying is that max we can buy with 6 is max we can buy with 4 here and 4 here and 4 here, but it doesn't really work like that. Okay, so I guess I'm kind of stuck because let's say I use this amount of budget for my sub trade, and how do I redistribute it? Good question. That's a great question, and I'm not sure. So let's. Oh, great. Has not bought a stock, and then, oh my days. Oh, why did I not think of that? Consider 2 cases. Buy the stock and max profit. Oh my god, but I have that. But what about the budget? What about it, bruh? Oh my days, I know I'm doing this way too complicated. So let that max profit be 0, and then we have oh my god, bro, hell nah. So max profit, I have to rewrite this whole thing. So max profit is that I'm doing this way too complicated, like way too complicated. Way too complicated. We have left the budget, so I don't even need B. I mean, no, I don't need it. So we need to modify the signature of the function. And now profit, cost, and then max profit we can achieve given that our budget is something. Okay, I have to revert all those changes. That's awesome. So if I say we have some budget left, right? So I pass in budget, and then this whole ugly thing gets commented out. So let's go through our children. So for int u in gv, if u doesn't equal p, then we want to try do dfs on uv with left, and then dfs uv and int cost is present v, future v minus present v, and present and present v divided by 2, and profit future v minus cost 0 and future v minus c1. And now if cost is more than left, if c left, then also try to compute it left minus. Good question. So we are pretending our parent did not buy. Int bought. Int cost is future v, no, cost is present v. If bought, then let's divide cost by 2, and then profit cost, then profit is equal to future v minus cost. And now if the cost is less than what we have left, so we did not buy here anything, and then left minus cost and 1. Okay, so after we've done that, no, sorry. So we need to get, if we don't buy, int come dp u come 1 dp left 1. And so now we have a cost and profit, and we want to do so dp vertex left equal to didn't buy is COM0 plus just COM0 and then dpv left 1 COM1 plus profit, and that's it. Maybe I'm not sure at all how this works. We start with the budget and that's what we are left with, and then our parent did not buy. What's C cost? Oh, that means our parent did not buy. So either we didn't buy or we bought for the reduced price of. Okay, now it passes in this case, and this case, and this case, and just not this case. How did you get to 10, bruh? So, given what we have, in which vertex we have, what was our budget, and how whether our boss bought or not. This means we did not buy. So either we did not buy, or we bought and we get also the profit. So don't need this disgusting. How did I get 8? How is that possible? So you start with that my budget is not 6, and if with budget 4 I can get profit of 4. Okay. If my parent did not buy anything, then with budget 0, 1, 2, 3, 1, 2, 3, 4. So with budget 4 can't buy anything. I mean, I can still not buy. So not buy 4 is DPU. How is that even possible? No, don't submit. No, I didn't want to submit. That was a mistake. How do I have a left 40? How is that possible? One, two, three, four, one, two, three. There isn't. Oh, okay. So I try to go into vertex 1 that I have a budget of 1 left. Zero, zero, and we profit 6, but we have to have the budget for it first. Because, okay, let's say that I don't even have the budget for this. So we do this, and then what? Well, cost less than left, right? And if cost then left, then DPV left, bought max DPV left, bought, and finally plus profit. Okay, still one case doesn't pass because I somehow get 16. How you get 16, bro? So my budget is 10. So I can get for 8. I can get a profit of. So I buy here for 4. This puts this at 3 and 4. So for 10, I can buy 3 plus 6 is 9 plus 7 is 16. 4. Okay. Okay. Let me copy this. Let's check this out. So in vertex 1, we have a budget of 10 left. We did not buy anything. So how is this free? We will find out here. So if we are left with a budget of 10 and our parent did not buy, then we can get free, I guess. If our parent did buy, we are left with budget of 1, 2, 3, 1, 2, 3, 4, 5, 6. Well, it should not be the case. So if we are left with 10 minus, so with 6 money, then we can get profit of this much. That's fair. let's say we are here. We have how much left? This is vertex 1 with whatever, vertex 2. Now we are in vertex 0. We have 10 budget left. We did not buy anything, and the PV left bought is 0. Well, why is that? Well, come 0 means that I don't buy. How much can I get best from my child? Well, the answer should be 6, but that is not the case. Because if I have this much budget left, then I am running into the same problem I had before, and I'm already at 1 hour mark, and I am not even close to being finished, and I still have a lot of things to do. Well, with this much budget, if I go over I'm at the same problem I was before. If with this much budget, I'm brain dead. I'm brain dead. I should be able to solve this, but I'm just brain dead. I don't have 2 hours for this shit. I'm overthinking it probably insanely. Yeah, this is the problem, because I don't know which children to buy. I just don't know, because I could buy them with any combination. That's the problem, because he realizes I can buy this guy with, I don't know, 6 budget. I can buy this guy and this guy discounted, so I buy both of them, and suddenly it doesn't add up. So I probably then I need to do some micro DP, I guess. So if this is even buyable, right, then we wanna try to buy this. But what is the most we can buy without budget? So that's a mini knapsack in and of itself. So let's change this to come 0 is this, and then comes 1 vector int comes 1 pushback. So this is what we can buy, pushback, and it will cost us this much. I mean, I really am going to do mini knapsack in each vertex. That's crazy, dude. What the hell? So I'm running into the same problem, but this time I know how to solve it. Hopefully. Haha. Oh, no, I don't, because I say that this is my budget. I need to compute it for all budgets, just like I had before. And then I need to try all orderings, and I am completely stuck. N times budget squared. See the budget squared transitions in each vertex. What the hell? Oh, I could just make a tree. I am dumb. Whatever. So okay. Problem statement 3 for DPU state B. Fair enough, I'm at that part, so wait. Optimal profit by all children U. To do this, we compute auxiliary state subprofit state B, since we are solving for optimal. It's child node. Not all child can enjoy discounts. DP is 0. Okay, each subderivative. What is even the DP here, bruh? What the hell? And why you use a tuple, bro? Can't use a vector at that point. It's treated as an item. The sub3 budget sub as the weight. Awesome that I cannot read this. After all, after merging all child information, state is 0, so it's subprofit 1, P minus present U plus future U. I'm not sure this. Okay. Upper bound increasing. So cost, discounted cost, do not purchase parent node. Okay, sub profit. Okay, so sub DPU1, and what is V size? What's even U size, bro? What is cost? What the hell? I couldn't figure out the knapsack part. This is a difficult ass problem, dude. This is difficult. It's exactly what my problem was with this, is that well, let's say I have this amount of budget, and now if I is over cost and I bought at max profit, sub profit 0, what's DP1? Oh my god, bro. State 0 we did not purchase. The parent node did not purchase. Well, then it's either sub profit 0, which we didn't. Wait. Discount not available. Where is Python one word? One. I mean, I kind of understand that I'm just supposed to do knapsack, but this is ridiculous, bro. Ridiculous. That's straight up. That's crazy. So what did they do in here? Tuple, vectorid, and int, and they just pass the vertex itself. So I start with this. So I don't even do the budget. That's very interesting. I guess let's do it again. I'm gonna puke from this at some point. So int cost to present v present v divided by 2 int profit to what's sub profit? That's just go through the, because let's say I want to do knapsack. This is so misleading. I mean, okay. Did they really make it in that many languages? I mean, it's basically the same thing. So C#, Rust. Even AI can translate that. So let's say I have some budget. Do I really care about that? So, wait. What's sub profit again? profit e plus 1, I don't know. And then we want to run the FSUV. Then we want to go through budget, they say. Since I have this much budget. I don't understand this. Child profit I is max I0 is child profit I0 and child profit I minus J 0 plus DPU of J0 and then child profit I1 max child profit I1 and then it's so that means I'm doing a knapsack over okay, I would never figure this out, never. Then we do this, so dp vector I0 dp vector I1 is child profit vertex I, child profit I0 if I cost 0 dpv one max dpv I1 and make child profit I minus cost 0. No, this is cost if my parent bought. Now again if I bought, if my parent bought. That is weird, bruh. So if my parent bought, then max profit with budget I at vertex V if my parent bought is that, well, I subtract the cost needed for this and I get it. That's this pair, this one bought, and then we add profit or not profit. Where does this is cost, but where is future minus cost? Profit 1. If I cost 0, then cost 0 if my parent did not buy. So this is max dpvi 0. Then if my parent did not buy, I think it's the same because I am still buying. Almost got it, but and finally I have to modify this. So dp 0 I 0. So if my parent did not buy, so I was just missing the knapsack part, but other than that it's fair game. What is wrong with you? Oh my days, I cannot believe it. Knapsack on a, like I did a bunch of 3DP problems, but a knapsack on a 3 is crazy. Oh my god, bro. This was suffering. This was plain suffering. Three knapsack. Let dpijk be the max profit with in sub3 rooted at v with budget j if the parent did not k1 k0 buy if its parent did not buy its stock. The key is that given a budget and in a vertex W and computed answers for sub-trees, we need to do a knapsack on the child values, since we do not know which to pick inside of our budget. Approach when computing answers for vertex W, we first compute child profit ik 0, 1, where child which is the max profit we can get from all children having budget I and I don't actually even use child profit 0. I use it here, okay. Which is the max profit we can get from all children having a budget I. We can get from all children having budget I for them, having a combined budget of I for them and buying the stock at in vertex V. We compute this by going over the child vertices and recursively solving the problem. Recursively compute child vertices U and computing dp U for them, and then do a knapsack we go over we try all combinations of budget and budget left for that child. Just a look at the code. This is insanely hard to explain. Once we have computed a child profit, we can compute, but I'm not gonna cook anything. We can compute dpv by considering by doing a knapsack on taking slash not taking the current vertex on a not taking the current vertex. Okay, time complexity is something ridiculous like n times nb squared, where n is the number of employees and b is the budget. We do b squared work for each vertex, calculating child profit and OB. We also do OB work, computing DP for the vertex, but that's asymptotically less than O of b squared. Space complexity is NB for the DP table. Extra memory for child profit is OB, since after the child computes. That's not true, because if I just go straight down, then suddenly I have for the DP table and for the and child profit tables, the second table named can be allocated for can be in worst case. There is multi-cursor support. How did I do that? Can be in worst case allocated for all vertices if the tree is a line. Okay, I have enough of this, bro. This is a ridiculous problem. Even doing the write up 1.5